Artificial intelligence, commonly referred to as AI, involves computer systems designed to perform tasks that typically require human intelligence. These tasks include learning, reasoning, and problem solving. AI encompasses a wide range of techniques, with machine learning, or ML, being a significant subset. Other techniques involve natural language processing, which empowers machines to understand and process human language, as well as computer vision, which enables machines to see and interpret images and videos. Machine learning focuses on enabling computers to learn from data without explicit programming. Machine learning involves several key steps. Firstly, data collection is essential. The computer is fed a large dataset that represents the problem it needs to solve. Secondly, model training occurs. A machine learning algorithm analyzes the collected data and creates a statistical model. This model captures patterns and relationships found within the data. Thirdly, model evaluation is conducted. The model's performance is assessed using a held-out dataset. This ensures its accuracy and ability to generalize to new data. Finally, model deployment takes place. The trained model is deployed to make predictions or decisions on new, unseen data. There are several types of machine learning algorithms. Supervised learning is one type, where the algorithm learns from labeled data. In this case, both the input and the desired output are known. An example would be training a spam filter. Unsupervised learning is another type. Here, the algorithm finds patterns and structures in unlabeled data. Clustering data points into groups is an example. Reinforcement learning is a third type. The algorithm learns through trial and error, receiving rewards or punishments based on its actions. Training a self-driving car is a good example of reinforcement learning. AI and ML have wide-ranging applications across many industries. In healthcare, they are used for diagnosis, treatment planning, and drug discovery. In finance, they are applied for fraud detection, risk assessment, and investment management. In retail, they enable product recommendations, demand forecasting, and customer segmentation. In transportation, they are used in autonomous vehicles and traffic optimization. In education, they facilitate personalized learning and adaptive assessment. Finally, in entertainment, they enhance gaming experiences, streaming recommendations, and content creation. To delve deeper into the specifics of each of these areas, let's examine the components more closely. When gathering the data for machine learning models, the quality of this data directly impacts the performance of the model. The more comprehensive and representative the dataset is, the better the model will be at identifying patterns and making accurate predictions. This pre-processing step, data pre-processing, is also critical. It involves cleaning the data and removing irrelevant information, handling missing values, and transforming the data into a suitable format for the selected machine learning algorithm. Once the data has been acquired and prepared, the next phase is to select a specific machine learning algorithm. Many such algorithms exist, each with strengths and weaknesses that make them appropriate for different types of tasks. Some of the most common are linear regression, which is used for predicting continuous numerical values, support vector machines, which are used for classification and regression tasks, decision trees that partition data based on feature values to make predictions, neural networks, which are complex models inspired by the structure of the human brain used for tasks like image recognition and natural language processing, and clustering algorithms like k-means, which group data points into clusters based on their similarity. Model training involves iteratively adjusting the parameters of the chosen machine learning algorithm using the training data. The goal is to minimize the difference between the model's predictions and the actual values in the training data. This process often involves optimization algorithms like gradient descent that systematically adjust the model's parameters until the model's performance plateaus. After training, the model must be evaluated to assess its performance on unseen data. This helps to ensure that the model generalizes well to new data and doesn't simply memorize the training data. Common evaluation metrics include accuracy, precision, recall, and phone score for classification tasks, and mean squared error or R squared for regression tasks. Cross-validation techniques are often used to obtain a more reliable estimate of the model's performance. Once the model has been trained and evaluated, it can be deployed to make predictions or decisions in real-world applications. This could involve embedding the model into a software application, deploying it on a cloud server, or running it on a mobile device. The model's performance should be continuously monitored after deployment to ensure that it remains accurate and reliable. Furthermore, it is important to consider the ethical implications of AI and ML. These technologies have the potential to be used for both good and bad purposes, so it is important to ensure that they are used responsibly and ethically. This includes addressing issues like bias, fairness, transparency, and accountability. For example, machine learning models can sometimes perpetuate existing biases in the data, leading to unfair or discriminatory outcomes. It is important to carefully examine the data used to train these models and to take steps to mitigate any potential biases. Furthermore, it is important to ensure that AI and ML systems are transparent and explainable, so that people can understand how they work and why they are making certain decisions. This can help to build trust and confidence in these technologies. In the healthcare field, AI and ML are being used to improve the accuracy and efficiency of diagnosis and treatment. For example, machine learning algorithms can be used to analyze medical images to detect diseases like cancer at an early stage. They can also be used to predict a patient's risk of developing certain diseases based on their medical history and genetic information. In the financial industry, AI and ML are being used to detect fraud, assess risk, and manage investments. For example, machine learning algorithms can be used to identify fraudulent transactions by analyzing patterns in financial data. They can also be used to assess the creditworthiness of borrowers and to make investment decisions based on market trends. In the retail sector, AI and ML are being used to personalize the customer experience, optimize supply chains, and forecast demand. For example, machine learning algorithms can be used to recommend products to customers based on their past purchases and browsing history. They can also be used to predict demand for certain products and to optimize inventory levels. In the transportation industry, AI and ML are being used to develop autonomous vehicles, optimize traffic flow, and improve safety. For example, machine learning algorithms can be used to train self-driving cars to navigate roads and avoid obstacles. They can also be used to predict traffic congestion and to optimize traffic light timings. In the education sector, AI and ML are being used to personalize learning, provide adaptive assessment, and automate administrative tasks. For example, machine learning algorithms can be used to tailor educational content to the individual needs of each student. They can also be used to provide automated feedback on student work and to grade assignments. In the entertainment industry, AI and ML are being used to create more immersive gaming experiences, recommend content to users, and generate new forms of art and entertainment. For example, machine learning algorithms can be used to create realistic characters and environments for video games. They can also be used to recommend movies, TV shows, and music to users based on their preferences. While AI and ML have the potential to revolutionize many different industries, it is important to acknowledge that these technologies are not without their challenges. One of the biggest challenges is the lack of data. Machine learning algorithms typically require large amounts of data to train effectively. In some cases, the data may simply not exist, or it may be too expensive to collect. Another challenge is the complexity of AI and ML. These technologies can be difficult to understand and implement, especially for people who do not have a strong background in mathematics and computer science. Furthermore, AI and ML systems can be vulnerable to attacks. For example, an attacker could inject malicious data into a machine learning model to cause it to make incorrect predictions. It is important to develop robust security measures to protect AI and ML systems from these types of attacks. In conclusion, artificial intelligence and machine learning are powerful technologies with the potential to transform many different aspects of our lives. By understanding how these technologies work and by addressing the challenges that they pose, we can harness their power to create a better future. As AI and ML continue to evolve, It is important to stay informed about the latest advances and to consider the ethical implications of these technologies. By working together, we can ensure that AI and ML are used responsibly and ethically to benefit all of humanity. There are also subcategories that can be expanded on. For natural language processing, NLP techniques allow machines to understand, interpret, and generate human language. This is crucial for applications like chatbots, sentiment analysis, and language translation. NLP models often use techniques like word embeddings and recurrent neural networks to process and understand the nuances of human language. With computer vision, machines gain the ability to see and interpret images and videos. This is used in applications like object detection, image recognition, and facial recognition. Convolutional neural networks, or CNNs, are commonly used in computer vision tasks due to their ability to extract features from images. Then there is supervised learning, where algorithms learn from labeled data, meaning the input and output are known. Common examples include classification tasks like spam filtering and regression tasks like predicting house prices. Supervised learning algorithms include linear regression, logistic regression, support vector machines, and decision trees. Unsupervised learning, on the other hand, involves algorithms finding patterns and structures in unlabeled data. Examples include clustering data points into groups or dimensionality reduction. Unsupervised learning algorithms include k-means clustering, hierarchical clustering, and principal component analysis. Then lastly is reinforcement learning, where algorithms learn through trial and error, receiving rewards or punishments based on their actions. This is often used in training agents to play games or control robots. Reinforcement learning algorithms include Q-learning, SARSA, and DeepQ networks. Understanding the distinctions and applications of these different machine learning paradigms is essential for effectively deploying AI and ML solutions across various domains.